everyone, my name is Gloria and I'm Cloud Engineer at Oracle. Today I'll be showing you how to deploy a GPU machine on Oracle Cloud Infrastructure, install NAMD, and run a model using NAMD software with this runbook. Before we deploy this runbook, I want to talk a little bit about this architecture. So we have a single GPU machine running inside of an Oracle Cloud Infrastructure virtual cloud network. This GPU instance will have block storage with NAMD already installed and attached. After you deploy the stack in Resource Manager, all you have to do is SSH into the instance to access NAMD, making it easy to get up and running quickly. Now let's go into Oracle Cloud Infrastructure. Here we are in the Oracle Cloud Infrastructure console, also known as the OCI console. To access Resource Manager, we're going to go into the navigation bar and scroll down to Resource Manager. And from here, we'll create a stack. So this zip file can be found in the runbook resources. And we'll give it a different name. We'll call it NAMD. And make sure that it is in 0.11x Terraform version. So all of the following information is already pre-populated by the zip file. So as you can see here, we have several different GPU shapes, both bare metal and virtual machine. But for the purposes of this lab, we're going to use BM GPU 3.8. And we got to make sure that's in the correct availability domain. And essentially, the availability domain is the data centers within a region. We'll keep the GPU node count the same and the VNC type for GPU the same as well. We have 500 gigabytes for the block volume size, and we have all of the following pars for the NAMD software. So all we need to do is create the stack now. So once we're at the stack, we need to run the Terraform action apply. And so this job is going to run for about a couple of minutes, and as the job is running, you'll see the logs populating. Once the job is succeeded, you can find all of the information needed to SSH into your instance in the output section. As you can see, this will be the IP address that we will be SSHing into, as well as the private key. So what we're going to do is copy the private key, and we'll make a directory called NAMD demo, and then make a directory for our SSH. We'll create a key. And we'll save this. And then we'll make sure that we give it the correct permissions. So now with this information, we can SSH into our instance. So we're going to do and now we are in our GPU instance. Now that we're in our instance, we're going to run NAMD with CUDA with this script. It should take a couple of seconds. Now that that's finished running, we're going to run this Python script against the output file to calculate nanoseconds per day averaged over log timing statements. This is used to identify the performance and efficiency of the application using the current GPU-CPU configuration. And as you can see here, we have the mean time per step as well as the standard deviation. For post-processing, we're going to use VNC Viewer so we can use Visual Molecular Dynamics, also known as VMD, to analyze our models. Now let's go into CNC viewer, and as you can see, I created one with this information. We'll click into our password. And now that we're in here, we can just pick English. All right, now we're ready to go. So we're going to open up the terminal. And we're going to go into this folder. All right, now all we need to do is just type VMD, and now we're in. We're going to choose a molecule found in our folder. So, all right, let's look at some proteins. We'll look at alanine. So what we're going to do is load this file, and as you can see, we have our visualization.